Good morning, everyone. Welcome
Good
to the
morning.
October 2025 Zoom Citrus Seminar. Thank you for joining us. First, I would like to thank Deborah for her help at our Hendry County Extension office in La Belle. I also would like to thank Julie Carson from the Immokalee IPCs Center for her cooperation. Today's program offers 1 CEU for pesticide license renewal and 1 CEU for certified crop advisors. If you need CEUs, email me your name, email address, and license number. The title of the seminar presentation is Combining IPCs and Brassinosteroids to Prolong Young Citrus Tree Health. Our guest speaker is Dr. Fernando Alferez, Associate Professor and Citrus Horticulturist at the UF-IFAS Southwest Florida Research and Education Center in Immokalee. Dr. Alferez will present the latest information on the combined use of IPCs and brassinosteroids in two scenarios. First, the use of brassinosteroids to prolong tree health after IPC removal under HLB conditions. Second, the combined use of IPCs and brassinosteroids to recover HLB-infected young citrus trees, giving these trees a second chance to become productive. Dr. Alferez, it's all yours. Please go ahead.
Thank you, Mongi. Thank you for attending this seminar. Good morning, all. Today I will be presenting, just as Mongi said, a summary of the work that we have been doing in my program during the last 7 years or so to adapt new tools available for growers now to protect newly planted citrus trees against HLB. And as we just said, I will be talking about IPCs and brassinosteroids and what we have learned so far, and also some promising work that we are doing right now. So this is a summary of take-home messages from today's talk. The first one is, as we already know, and we are knowing, IPCs are currently the most efficient tool to protect young citrus trees against HLB. Not all varieties perform equally under IPCs, and that is something that we have learned in the last couple of years. And the last point that I want to talk about is that HLB-affected trees, especially if they are young, can recover by later IPC installation and some aid. For instance, using brassinosteroids that promote tree growth and defense responses in young citrus trees. Just for some background, in the current situation of endemic HLB, this is the rate of infection in a citrus grove if at planting no protection measures are taken. So by 6 months, you can see how about 80% of the trees are infected by HLB, and within 1 year, all trees are HLB positive or infected. A tool that many growers are now using is the individual protective cover, or IPC, and the mechanism is very simple, it's psyllid exclusion, and I'm sure you are familiar with it by now. In my program, we have demonstrated that IPCs work, and we just need to look at this picture to agree. On the left, you have a tree that was planted 30 months ago without the IPC protection, and compare that to the tree on the right that was covered with IPCs at planting. Both were planted the same day, but you can see how the protected tree is taller with a denser canopy, and this tree is ready to bear fruit next season. The unprotected tree with a declining canopy will barely set any fruit at all. So I will talk about this later more in depth. Now, because IPCs work, now they are adopted by many growers, and this is how many commercial groups look like these days. And you can see them all over the state in these days, okay? And this is a summary of what we know already. We know that IPCs are an effective strategy to maintain trees free from HLB, and they can also reduce canker incidence, but they do not exclude all pests. That means that regular scouting is still necessary. We still need to scout those trees. And controlling secondary pests remain really important. And last but not least, fruits produced under IPCs have better internal quality, and also IPCs improve fruit yield in those trees that are protected. Now, elaborating a little bit on what I just said, in these graphs, you can see how IPCs almost suppress canker incidence. This is the orange plot as compared to the blue plot in the trees that were not protected. Okay. However, other diseases like greasy spot and sooty mold are favored by IPCs, and this is probably because of the environment created by the covers and the higher relative humidity that we get inside the covers. So again, proactive scouting and action are required to maintain healthy trees. Okay. Now, what we have seen, what we have seen, and this is really important, is that trees under IPCs produce more fruit and of better quality than if they are not protected. In other words, IPCs give these trees a competitive advantage. And here I'm showing production of 3 consecutive seasons after IPCs were removed from Valencias grafted on Cleopatra rootstock. And you can see how on the left graphs here, yield is consistently higher in the trees that were protected with the IPCs. Now the picture shows how the fruit looked, and this was in the second season, actually here. And you can see that the fruit was larger and with better coloration. And talking about fruit size, on the right, you can see how some data on fruit size, most of the fruit was of larger size if the trees were protected, okay? About 70% of the fruit was of 60 millimeters or more, which is a really nice size for this fruit. Not only that, quality was also improved by the use of IPCs. Just look at the bricks, okay? Just look at the bricks for 3 seasons. Bricks were higher than in the non-protected trees. Of course, there was a decline in the second and the third year as the trees were getting infected. Still, this is a significant difference with the trees that were not protected. You can compare, for instance, 9.6 versus 7, okay? And I want to note here that harvests in these Valencia trees were done in mid-February, which is really early for this variety. But the reason is that if we waited longer, we would lose all the fruit in non-protected trees due to drop. So we could not make comparisons. So the message here is that probably if we wait longer and we harvest in March or April, we would probably get better bricks numbers if we harvested at that time. We also know that not all varieties grow well under IPCs, and this is a great tool for sweet oranges and some mandarins like Tango or the Marcot family in general, also grapefruit and pomelo, but it's not good aid for early brights. And for sugar bell, they only help for the first year. Keeping them for longer in this variety in sugar bell is detrimental for the tree growth because they are very vigorous. Okay, and here a couple of pictures of what I just said. You can see how early bright trees are showing severe dieback under the IPCs. And on the contrary, you can compare a tango tree in the front, just here, in frank decline, as it was not protected with IPCs, and then in the back, taller, healthier, uniform in size trees, thanks to the IPC protection. And we have been reporting all these results in the last few years. Here are some examples, and also the media has been reflecting our work regularly. And I have to say that the adoption of this tool is being massive. And just an example, in the CRAFT program, virtually all new plantings are now using IPCs as a tool for protecting the trees. And we estimate that at least 17,000 acres are using or have used IPCs in the recent past. And the numbers seems to be increasing. Okay, so now the problem actually arises when it's time to remove the covers. In this graph, I show the HLB infection rate for 36 months. You see how non-protected trees are 100% infected in the first year. This is the white dots, okay? Now we protect the trees, the black dots now, they are not infected, but once we remove the covers, just here, the rate of infection is actually the same. So by 1 year, all these trees will be HLB positive. Now the question is, or the question we made ourselves is how can we protect the trees, or how can we prolong tree health further, okay? Now, a few years ago, there was a report showing that Brassinosteroids, which is a relatively new plant growth regulator that has been around for about 40 years, Brassinosteroids were able to reduce HLB incidence in citrus trees, okay? So we started to look into this plant hormone because there are increasing number of reports in other plants, mostly model plants, showing how Brassinosteroids may modulate processes in which we are interested. Now, from root growth, root development, to resistance to diseases, and even a control of fruit maturation. So our approach was, if this plant hormone is producing these effects, can we combine its use with the use of IPCs so we can prolong tree health after IPC removal? We applied and we got a grant from USDA to test exactly this. And I will give you in the next slides a summary of what we have been doing here, okay? Now, we have been working on several trials in our research farm and at SWIFREC, and in commercial farms with grower collaborators on different varieties. Here is a summary of trials. We have been working with mandarins, with sweet oranges, with pomelo, also with grapefruit. And this is how a typical tree looked like 6 months after IPC removal. Okay, these trees were covered with IPCs for 35 months. And then we started a treatment with Brassinosteroids for monthly for several months. And I'm showing here 6 months because after that, what we see is just a gradual decrease in Brassinosteroid effect on bacteria population control. And we start to see HLB incidence in these trees by 8 months. But here you can see how the trees that were treated once a month with Brassinosteroids showed more flushes, okay, and denser canopies in general, that the trees were just covered with IPCs with no Brassinosteroids applied after we remove the covers. Okay, so I have to say that this effect that we see in the Brassinosteroid treated trees is maintained for at least 2 years after we remove the covers, even though the trees are getting infected. So our interpretation here is that Brassinosteroids are improving tree vigor. So they grow faster, and they are also conferring to these trees some tolerance. And I will talk about that a little bit later. Now, here you can see how trees were still negative with brassinosteroid treatment 6 months after IPC removal. Look at the green boxes here. This is the combined treatment, IPCs and then brassinosteroid treatment. Okay, as a reminder, we do this by PCR, and we look into the number of cycles that we need of PCR to detect the bacteria. So always the less number of cycles, the more bacteria is present. Okay, and the consensus is that below 36 cycles, the trees are positive for HLB, and above 36 cycles, they are negative. And here you can see how brassinosteroid treatment maintains the trees free from HLBs, if IPCs are used first. Okay, so they maintain the trees free from HLB for 6 months after IPC removal. And after that, as I said before, we start to see and to detect some bacteria in these trees. Okay. Now, we are continuing now the work with brassinosteroids, just looking into just the effect of the plant hormone on newly planted trees without any other protection. And we have found that indeed in trees that are planted healthy, even without IPCs, just the brassinosteroid treatment delays the progression of HLB disease. So by 12 months, we still have some trees, about 20% of the trees that are still testing negative for HLB. Okay. And not only that, we have also seen that there are less psyllids per plant and less eggs being laid if we treat those trees with brassinosteroids. So this indicates that after brassinosteroid treatment, plants become less attractive to psyllids. And this is really interesting. And is a direction that we are following now. And not only that, several pathways related to plant defense are coordinatedly upregulated at the molecular level with the treatment with brassinosteroids. For instance, the salicylic acid pathway, both upstream and downstream salicylic acid, and the jasmonic acid pathway, again, both upstream and downstream the jasmonic acid pathway. Okay, and also a family of antimicrobial peptides with demonstrated role against HLB, against SILAS. Okay, again, these responses seem to be coordinated after brassinosteroid treatment. Look at the expression, is really similar in all cases. Now, going back to our previous scheme, we have seen that brassinosteroids in young citrus trees are able to at least modulate some processes in which we are interested, like disease resistance and increase in plant biomass. Now, we are ready in my program to unravel or to start unraveling how this plant growth regulator interacts with other hormones in citrus to modulate processes like plant immunity resistant to different stress, including but not limited to this disease resistance, and also fruit development and maturation as the tree enters into the bearing age. And this is one direction that my program is following now. Okay, and for this we are collaborating with colleagues in Valencia, Spain, because since there is no HLB in Valencia, at least yet, we can actually look into the effect of brassinosteroids per se. So we have established parallel experiments in both locations with trees on the ground in their place in Valencia, and trees both in the ground and in pots here in Florida. And we have funding from the Spanish government and the regional Valencian Valencian government just to do this work. So since there is no HLB in Valencia, we can actually explore the effect of the brassinosteroids per se without any other interferences. And as you know, there is a compromise or a balance in the tree between resources being allocated for growth or for tree development and resources being allocated for disease resistance. And plant hormones can modulate this balance. And among them, brassinosteroids can modulate this balance. And we want to understand how this works in citrus under HLB. So this is a really nice way to do this. So this is a picture of some trees in our Valencia site 1 year after planting and monthly treatment with brassinosteroids at the same rate that we are using here. So you can see here clear differences in tree growth. This is a control tree, and this is a brassinosteroid tree 1 year after treatment. After treatment started once per month, okay? And this is our team in Valencia. And here is part of what we are doing at our center in Southwest Florida. And you can see a control non-treated trees as compared to a brassinosteroid treated tree. And clear differences are being seen here. So in terms of canopy density, canopy development, trunk thickness, and even branching and fruit set. You can see some more lateral branches here than here, and even some fruit already set, and no fruit in a control tree. Okay. And when you look into the roots, you can actually see denser root mats with the treatment, and also new root growth that is more abundant with the treatment with brassinosteroids. Okay, and regarding lateral branching, as I said before, it is significantly improved if we treat these plants once per month. We were doing different treatments every other week, once per month, or every other month, and you can see how the best treatment, and this was significant as compared to the control, the best treatment for improving lateral branching was treating once per month. And this is actually important because lateral branches are the fruit-bearing branches, so these trees are getting ready to produce fruit. Okay, now with all this knowledge that we have been accruing in these trials, we want now to answer one question that we are getting. And the question is, can we recover infected young trees? So imagine that you planted a grove and you did not use IPCs at the beginning, at planting, and now the trees, it's been like 1 year or more, and the trees are infected, they are in frank decline, okay? So can we recover these trees and give them a second chance to survive and become productive? So to answer this question, we started a trial about 2 years ago. So in February 2023, we planted 90 trees in our center, and we left them unprotected for 1 year, okay? So after that, all of them were HLB positive and in decline. So what we did then was 1 year later, after 12 months, we kept 30 of these trees unprotected. Now, another group of 30 trees, we retrofitted IPCs on them. With that, we were avoiding reinfection. And the last 30 trees, we covered with IPCs, and we started a treatment with brassinosteroids once per month. With that, we were avoiding reinfection with the IPCs, but we were also improving growth and inducing defense responses. Okay, and this is what we are finding this during this time. So this is how the trees looked after 6 months. The control trees are still in frank decline, but now look at the trees that we covered with IPCs. They are starting to build a modest canopy, okay? And the trees that we are doing the combined treatment, retrofit IPCs and then Brassinosteroids once per month, they are showing a better canopy with some lateral branching already being established. This was after 6 months, but look what happened after 12 months. Okay, after 12 months, we got the control trees are almost dead. They will not set any fruit ever. The trees that were only covered with IPCs are now having a nice canopy that is being developed under the IPCs. But look at the trees that we covered with IPCs and we have been treating with Brassinosteroids. This is a more dense canopy. And if we zoom into this canopy, if we zoom into that, you can see large healthy leaves with no HLB symptoms and even some flowers. We are looking forward to our first harvest next spring, actually. And when you look into the bacteria population, just look into the dark green box after 12 months. And you can see how we need significantly more cycles to detect the bacteria. So there is actually less bacteria present here. And this is a clear indication that we are helping the tree to kill the bacteria. And of course, we are trying to continue this work at least until next spring, because we believe that this is really, really a promising approach for these trees. So in conclusion, what we have seen during all this time working is that IPCs are currently the best management practice for keeping young trees free from HLB in Florida endemic areas. We know that IPCs improve tree growth, fruit yield, and quality. We are learning how Brassinosteroids are able to induce several coordinated defensive responses in young citrus trees, and they also improve tree growth. And this is very interesting because they are doing both things at the same time, which is remarkable. And also, if no infection occurs, if no reinfection occurs, so if IPCs are used, Brassinosteroids may recover young trees up to 3 years old if they are already affected by HLB and in decline. And these trees in recovery are producing fruit. So we are looking forward to quantify that fruit and to actually assess the quality of this. And this was my talk for today. So I want just to thank our funding agencies, CRDF and USDA, for the support during this year, during these years. Also to the Tree Defender for the gift of the IPCs that we are using in our trials, and then to some international programs like the Fulbright and some programs from the Spanish and Valencian government, because they are allowing us to continue the work with the Brassinosteroids in the next year or so. And thank you all for your attention. And if you have any questions, I will be happy to answer them. Thank you.
Thank you, Dr. Alferez. Thank you all for attending, and we will see you next time.